Hi everybody, Scott Stanchfield here. Let's talk about slot APIs inside Jetpack Compose. Throughout the years, we've used functional decomposition to help break down functions, making them easier to understand and have reusable chunks. Think about way back at the beginning of time. You might have had a long main function that did everything inside of it, and there might have been lots of chunks of reused code inside there, as well as it's just super long. And when you get down near the bottom of the function, you can't remember what's happening at the top. We break those down by pulling out the common code into some functions, as well as maybe breaking down chunks of the bigger function into smaller functions to make it easier to understand. In our composables that we wrote for the screens, we might have some common functionality like a toolbar at the top and a bottom bar at the bottom, and then some specific functionality in the middle for the screen that you're on there. And we can manage that in each one of those screens by setting up a layout, calling toolbar stuff, calling bottom bar stuff, and that's fantastic because then we get the functionality pulled out for the common toolbar stuff, the common friends list, things like that. However, think about every single one of those screens. They all need to define that same layout and pass the same modifiers to the toolbar stuff and the bottom bar stuff to make sure that it's going to appear the same in all our screens. Otherwise, if we modify 4 out of 5 screens to tweak the way the layout is set up, something's going to look or feel a little bit off. It's really hard to keep these things in sync. So what we'd like to do is have some kind of function that can manage that structure for us. And hopefully we can just pass in chunks of the user interface that that function will manage. And that function handles the layout, it handles the setup of the modifiers. And that way we have that commonality for the setup that all the screens can use and yet have their own special functionality that's specific to that screen still be present. So let's take a look at something called the template method design pattern. And design patterns have been around for eons. There was a book written in the late 90s that described several software design patterns, and it was called Design Patterns. And I used to teach a design patterns course at Johns Hopkins. I'm going to talk a little bit about the concept about template method before we actually apply it in Jetpack Compose. So the basic ideas of template method pattern, and I think the easiest way to think about it, is that you're defining an algorithm where some of the steps can be replaceable. The algorithm can be fairly simple, it can be really complex, it can reuse lots of those steps anywhere it wants, but the idea is that you're plugging in some different changes. And when I talked about design patterns in my class, I used to compare it to a Gilligan's Island script. If you've ever seen the show Gilligan's Island, every episode is exactly the same. Somebody comes to the island, they do something specific that's within their talent, then they get rescued and leave the castaways behind, and then Gilligan gets hit with the skipper's hat at the end of the episode. It's always exactly the same structure. And we can think about that same type of thing in programming, where we have an algorithm that represents that script, and it has little places that you can replace for the specifics for that episode, like who is the person that comes on the island, what that person's special talent is, whether they're a singer, an actor, or a dancer, or whatever. And there's two main ways that you can implement this pattern. One is polymorphic, and the idea is you create an abstract class that's going to represent the thing that holds the template method. And he has a function in there that's usually final that calls several steps. Each of those steps are abstract methods, and that can be overridden by different subclasses. That's a really nice approach to this. But the problem is, once you've created the instance of this, you're done. You can't change those implementations. A better approach is a strategic approach. This is using the strategy pattern as a helper for the template method pattern. And the idea with the strategy pattern is you're just passing in functionality that you want to call. Usually these two functions are used together very tightly. So each of the steps in that template function are callbacks. It can be a callback via an interface. It can be a callback as a functional parameter. There's a bunch of different ways to implement those. Again, the template function is going to be usually final, and it's going to call those steps. The steps can be implemented either as properties in that class, so you can plug them in, or just function parameters to that template function. So let's take a look at what problem we're trying to solve with template method in general. And just get Android out of your head for the moment. We're just going to talk about a basic object-oriented user interface. And in this object-oriented user interface, we're going to define a panel. This is going to be something that's going to display things on the screen. And a component is just a part of a user interface that's going to be displayed. So it could be a text field, it could be a button, things like that. And these terms, if you're familiar with AWT or swing in Java, are going to look kind of familiar. This is kind of a dumbed down version of what might be happening inside Java for user interfaces. So if we define this abstract class for a panel, the kind of naive way of thinking about this in object-oriented definition is to just create subclasses to define how we're going to display things on the screen. So at the top level, we have an abstract function called display, and then in the subclasses, we're going to implement display, and we'll implement it differently based on what we want to do. So let's think about some of the things we might want to implement, and I'm just going to talk about two aspects of the user interface. One is a border that goes around things, which may or may not be present, and then the second is the algorithm you're going to use to arrange the children inside the form. Now let's think about if we just had two choices on each of those. So one, border or no border. Two, form layout versus a grid layout. And keep in your mind, there are a lot more layouts than that, and there's a lot more types of borders than that. But just with those two, we end up getting an exponential explosion of subclasses here. So a form layout without a border, he's just going to arrange the children. A form layout with a border is going to draw a border and then arrange the children. A grid layout without a border is going to arrange the children as a grid. Grid layout with a border is going to draw the border and arrange the children in a grid. So think about this exponential explosion. You basically have a cross product of all of the possible layouts and all of the possible borders, or no border. That's a ton of subclasses you're going to create here. And it's incredibly inflexible. If you ever want to change that layout or change the way the border is being displayed, you have to create a new instance of that entire panel. So really not a good way to approach user interface. Template method really helps you out here. So the first one we're going to look at is a polymorphic example of how you can do this. And this is really what they push in the design patterns book, but there's many other better ways to do this. And my favorite is really when you combine template method and strategy together, and it really makes things much more flexible. But we'll start with the polymorphic approach. And the idea here is that we're going to define an abstract class that has a little function here called display. And this function called display is our template method. And what he's doing is he's saying, I'm going to call draw border and I'm going to call layout. Those are the replaceable steps that we're providing. And those replaceable steps in this case are defined by these two functions, draw border and layout. And these are generally either abstract functions or open functions that you can override. So I'm defining draw border as being a function that doesn't have any code inside of it. So it just doesn't do anything by default. But because it's open, I can override it in subclasses to add a border. The layout function, I'm just making it abstract because I don't want to define a default way to lay things out. I want the subclass to decide that for me. So then we're going to define subclasses. And what I did just to make things a little simpler is I started off with kind of an intermediate subclass, form layout panel or grid layout panel, which just defines that layout function. I also made these abstract so people aren't going to just create instances of these. Each of those has two subclasses, form layout without border panel, which really doesn't do anything. It's just calling the first one. It's just using that layout. And then form layout with border, which just overrides border. Similar on the grid layout side. So by using subclasses, we can override these pieces. But the nice thing about this is you don't have to define these subclasses unless you need them. But you still have a lot of this exponential explosion going on. And that's really where this kind of falls flat. If you have just a few things you want to override, it's really not too bad. But as soon as you have 2, 3, 4, 5 different types of aspects that you want to override, this becomes very, very hard to manage. So a better approach is to use the strategy pattern. And the idea with the strategy pattern is you're going to pass in the function that you want to implement. And a real basic way of looking at this is using interfaces. So if we define an interface for each aspect we want to replace. So the border interface has a draw border function, layout manager has a layout function inside of it. And then our panel here is going to be the one true panel. We're never going to create subclasses of him here. We're going to plug in the functionality we want. To do that, we have properties for border and layout manager here that we can actually just pass in. Note that I'm setting these both up as initialized to null. So I'm saying don't use a layout manager, don't use a border. Probably not a good idea to not have a layout manager, but hey, if somebody doesn't want to lay out the kids, they don't have to. Our display function, again, this is our template method. He is going to say, if I have a border, call draw border. If I have a layout manager, call layout. Boom, nice and simple. We don't have to create any subclasses. Then we can start defining the actual concrete strategies that we're going to pass in. So if we had a line border implementation, this says how to draw a line around things. A form layout that says how to lay out your children. A grid layout, how to lay out your children. And then these stay fixed. We're not going to use subclasses of them. They're just separate little pieces that we can plug in. Then when the caller is setting up the panel, he can plug those pieces in. I'm going to use the apply function in Kotlin here to make this a little simpler so that while we're defining the panel, we can just plug in these values. And what apply does is it says, take my receiver panel, pass it in as this for the body, so it becomes the receiver of the body, so that the panel's border and the panel's layout manager are getting assigned. At the end of the apply function, it just returns that same receiver, so the panel gets returned. So apply is great as an initializer here. So I'm going to create a panel with a line border and a form layout, create a panel with a line border and a grid layout. Very easy to plug these things together, and very, very flexible. But since we're talking Kotlin here, we can take advantage of functional types. So if we replace these using functional types, it's much, much cleaner in my opinion. So now we have our overall panel defined here, and we don't have to define those interfaces. We're just going to say a border is some function that doesn't return anything. Layout manager is some function that takes a list of components and doesn't return anything for it. Now we might want to, for the border, pass in some kind of canvas so that he can actually draw on the screen. But you can have whatever function parameters you'd need for that for this implementation. This is just trying to show you the structure of how this works. So once again, our display is our template method here, and we're going to call, if we have a border, we're going to invoke it. Now with a functional type, invoke is always present as a function call you can call. So if you had, if border was not nullable, we could just say border paren. That actually behind the scenes calls border.invoke. So what this does is it says, if I have a border, call invoke. Alternatively, we could have said border ? .let, and then inside it paren, and that would have worked just fine. But I find this a little bit cleaner to read because you don't need the extra for each around it. So if we have a border, call it. If we have a layout manager, call it. And then we define the common stuff as functions, or you could have these defined as values that have the value is a lambda. So we have our line border, how to draw them, our form layout, grid layout, how to use those. And then in our caller, we can just pass those in. So we create our panel and say border is a reference to the line border function. Layout manager is a reference to the form layout. And similar here, line border and grid layout. Or if we want to actually plug these in using lambdas on the fly, so we have some custom work, we can say border equals curly brace, call it. Layout manager equals curly brace, call it. Boom. This should start looking a little bit familiar to what we've seen in Jetpack Compose so far. Now, if we want to do this using parameters, instead of setting up a separate set of data to pass in, this becomes even much more applicable to us when we're defining things in Jetpack Compose. So here we have this display function now takes a border and takes a layout manager as parameters. And the nice thing about this, if we look at the previous example for a second, in this example, we'd have to constantly reassign the border and the layout manager if we wanted to do things differently on each run of display. With this approach here, we can just pass in different values each time we call display rather than having to update those parameters, those properties. So in this case, we can see that here, I'm going to call display, passing in the border and the layout manager, call display, passing in border and layout manager, and so on. And we really, for this example, this really, if we think about how AWT and Swing work, this doesn't make a whole lot of sense, but just kind of roll with me. It's really just the function call that we're interested in here, because that's what we're going to apply to Jetpack Compose. So if we take a look at an implementation of this inside Compose, you've already seen it. That's this scaffold function that we've used as the top of several of our screens. And what the scaffold function does is he has several functional parameters that represent the content that you want to put in different chunks of the user interface. So the scaffold breaks up his screen to look something kind of like this. This is basically two views of the same screen. The first one here is just showing you where the top bar is, where the bottom bar is, where the content goes, and where the floating action button goes. Personally, I'm not a fan of floating action button because it does cover up something behind it. And most of the time, you get a little bit lucky on that, but a lot of times there'll be some text underneath it. I'm like, I want to read that, and I can't read it. So not a fan of floating action buttons, but a lot of user interfaces use it. You'll see that in Gmail, for example. So this is saying where it's going to place those. Now the drawer content is a navigation drawer that slides in from the side. So think about this as being on top of this other user interface. So he slides in on top of it when you swipe your finger over, or tap a little icon on the top bar to make it expand. Scaffold is a template method. And what they do is they call this a slot API, where they call each of these chunks that represent portions of the screen slots. And it's a specialization of the template method pattern, but all it really is just a template method. You're passing in functions to say what to do at each of these sections on the screen. So what we're going to do for our example here is implement a border layout from AWT and Swing. So if you've ever done any type of Java layouts, you've probably seen border layout before. It allows you to put components at the north and south of the screen, so that's filling the top and filling the bottom. And then for the rest of the screen, lets you put something at west and center, or west and east, if you want them on the sides. And then whatever's left over is considered the center. So we're going to implement this using a slot API and see how that works.